Hey everyone, we're going to look at number 6 in section 10.5, and the instructions are here to assume that this ratio, the absolute value of a sub n to a sub n plus 1 to a sub n, that it converges to rho equal 1/9. Basically what they're saying is, right, this limit as n goes to infinity is 1/9. And this is kind of the limit that you remember from the ratio test, right? And we've been using the ratio test in this um, uh, section, excuse me. In this, again, if this limit is less than 1, then the series that corresponding the a sub n series, so if I was looking at the series n equal 1 to infinity, say, of a sub n, then if this limit is less than 1, this series would be convergent. If this limit is greater than 1, then this series would be divergent. If it's equal to 1, then it's inconclusive. So I know that this series, since this limit is 1/9, that's what we're told, this series is absolutely convergent, actually, and therefore is convergent. So the question is, what can you say about this series, which is basically n equal 1 to infinity, a to 8, rather, to the n power times a sub n, okay? All right, and your problem might vary from this, and so your answer might vary based on that. So let's see, what are we going to do? Well, I'm going to use the ratio test on this. How's that going to look? Well, I'm going to look at the a sub n plus 1, which is what I have in the numerator here. A sub n plus 1 is just replace n with n plus 1, so I'll have 8 to the n plus 1 power, a sub n plus 1, and then dividing by well, I'm saying a sub n, so maybe I'll call this b sub n. I probably should be a little confusing here. So this is like b sub n plus 1 up top, and on the bottom is b sub n. But clearly, 8 to the n plus 1 is 8 to the n times 8, right? So I can divide top and bottom by 8 to the n, and I'm left with 8 up here, okay? So I'm going to pull that 8 out. Absolute value of 8 is 8, and then I'm going to pull it out in front here. And what am I left with? Just the absolute value of a sub n plus 1 times over a sub n. Sorry, I'm just stumbling over my words. So the limit of this, I can pull this constant multiple out, provided the resulting limit exists, which I know it exists because we're told up here it's 1/9, right? So I get 8 times 1/9, which is 8/9. 8/9 being less than 1, then the series converges by the ratio test. Okay. Now, think about this. What if your series, instead of 8 to the n, was summation n equal 1 to infinity 10 to the n a sub n, right? Just a slight change here, right? Well, notice what's going to happen. Instead of 8 to the n plus 1 over 8 to the n, I'll have 10, right, to the n plus 1 over 10. And I'll have a 10 here, and that 10 will come out. And I'll have that 10 here times what? 1/9 again. Well, then I would get 10/9, which is greater than 1. So we know this series would be divergent. And of course, if I had the series summation n equal 1 to infinity 9 to the n over a sub n, what's going to happen? Well, we're going to have a 9 here, right? And then 9 times 1/9 would be 1. And in that case, the ratio test would be inconclusive. So here, the ratio test, we know that this series is convergent. This one's divergent. This one's inconclusive. Okay. Hope this makes sense for this problem.